Scripting for the Web, WS300, Platt College. So let's talk a little bit about what programming is and what it does. Programming basically helps us to speak to computers in a language that they understand in order to tell them what we want them to do. You can't get a computer to do anything unless you tell it what you want in exquisite detail. They don't have any way to infer what you mean. And so this is why sometimes we run into problems. You and I maybe have an idea of what we want, and if we don't communicate that information effectively, we might be sent to the disco when we meant to go to the library. It's just like any other foreign language. You have to learn how to speak it in order to communicate effectively. So why do we use it? The reason why we use it is because it helps us work smarter and not harder. We can create useful tools that make tasks easier or be more entertaining. We can use it to create dynamic and personalized websites, games, animation, interactive elements, collect data from websites through an application programming interface. Facebook, for example, and its feed is an example of technology that JavaScript is a part of. So how does this relate to the web? There are more than just the languages that I have listed on this slide, but there's basically two broadly categorized types that we concern ourselves when it comes to programming for the web. Client-side languages execute their code in the browser, so they have to be interpreted by the browser. Server-side languages execute their code on the server, which then serves up the code for the browser to then render. PHP is an excellent example of a server-side language, and JavaScript is an excellent example of a client-side language. JavaScript can also be compiled on the server before it is served up, but that's a different subject for another course. We're primarily concerned with JavaScript as a client-side language when it gets executed and interpreted through the browser. So how do we get JavaScript into our HTML? I know that you guys have seen these script tags before. We can write it directly on the page with the script tag, and we can write it externally with the script tag and the source attribute. It is good to note that JavaScript is commonly used alongside HTML, so much so that in HTML5 you do not have to specify the language in the script tag unless it is something other than JavaScript. You can place script tags anywhere in the HTML document. The current best practice is to place it at the end just before the closing body tag. There will be some other things that will suggest that you put them at the beginning or put them in the head or other things like that. So there are plenty of ways to execute JavaScript, but we will be primarily putting it just before the closing body tag. So let's talk a little bit about JavaScript. Now, this is a very brief history, and basically there was a need to create web pages that were interactive, and Brendan Eich of Netscape created what we now know as JavaScript. And this is the name that stuck. Initially, JavaScript, I think it was MochaScript, LiveScript. There were a couple of working titles for the script as things were developed. So the browser wars throughout the early 2000s are part of the reason that ECMA 4 was scrapped. Version 3 got renamed to 5. There was this really cool thing that happened in 2005. This guy, Jesse James Garrett, he wrote a white paper which brought about the implementation of Ajax, which we will talk about later on in this course, and the renaissance of JavaScript, which then turned around and led to the creation of JavaScript libraries like jQuery and MooTools. From there, so much stuff, right? We have React and Angular and Vue, and there's all these incredible JavaScript libraries that each are designed to do different things. But we're going to focus primarily on jQuery just to kind of get our feet wet with how a JavaScript library works. And it's one of the most useful ones that is available to us today. jQuery does a lot of things that web developers need. So when we talk about JavaScript and you don't want to say the whole mouthful JavaScript, call it JS. Don't call it Java. JavaScript is not Java, so please stop calling it that. JavaScript is a high-level interpreted scripting language. It uses the ECMA script standard, which I'll talk about in a minute. The host environments interpret JavaScript, so that would be your browser, or if you're using Node.js, another fantastic JavaScript library, your server's environment would interpret the JavaScript. JavaScript's initial design was influenced by programming languages like Self and Scheme, and Java is an entirely different language. Java was initially developed by Sun, and because it was the hot new thing, that's how JavaScript got named JavaScript. A high-level programming language in computer science is a programming language with a strong abstraction from the details of the computer. In essence, it's closer to human language than machine language, which makes it easier for us to understand, us as humans to understand and to write. It is an interpreted language, so it's a type of programming language for which its implementations execute instructions directly and freely without being compiled, like Java, for example, is a compiled language. The compiler would go through the whole process, check for any kind of errors, and if there were none, it would compile the script, and then that compiled script basically would be broken down to little bits of information, and that would go directly to the computer. The interpretation was part of the compilation. That's how it would interface with a computer. JavaScript, on the other hand, doesn't get compiled. It gets interpreted on the fly. So that's why it's a different kind of thing. It's a scripting language, which means it's a programming language for a runtime environment that automates the execution of tasks. And so scripting languages, like I said, are often interpreted rather than compiled. VBScript, JScript, which is Microsoft's ancient version of JavaScript, and ActionScript all use this same standard. ECMA stands for European Computer Manufacturers Association. And the host environment is a browser, as I mentioned before, and in the case of Node.js, it's a server. Browsers have a specific JavaScript interpretation engine built into them. Although there are similarities between JavaScript and Java, including the language name, syntax, and respective standard libraries, the two languages are distinct and differ greatly in design. As I mentioned earlier, JavaScript is a trademark of the Oracle Corporation in the United States. It is used under license for technology invented and implemented by Netscape Communications and the current entity known as Mozilla Foundation. Why JavaScript? This language, built by Brendan Eich, was essentially created in 10 days, but it was specifically intended for use within web browsers and to make HTML pages more interactive. Now that the great majority of browser manufacturers have agreed to adhere to the set standards, it is being supported in a more consistent manner across all browsers. Google is your best friend when trying to figure stuff out. Google searches can point you to JavaScript documentation and forums, questions from folks who are having a similar problem to you. The web has been around for a very long time, and it is likely that someone else has run into the same problem and asked a question and gotten an answer. It's going to be part of your learning and your training to up your Google foo and get really good at asking the right questions in order to get the right answers. Let's talk a little bit about syntax. The syntax of a language can be related to grammar, and in speaking languages, for example, there are nouns and there are verbs and there's sentence structure, and in programming languages, there are structures that do the same thing. You'll understand the concept of a loop in this language, and you'll understand the concept of a loop in other languages. The only difference is that its syntax might vary depending on what language you're in. For example, JavaScript and a lot of other C-based languages start indexing arrays at 0. Your loop counter would start at 0. If you're going to go through an entire array and loop through each item and then increment that index by 1 until you get to the end. This would be something that we would see as a standard thing across many different languages. Another language, called Lua, starts with an index of 1. Even though they're different languages, I understand that a loop still works the same way. I'm just probably going to start my incrementer at a different number. And that's one of the things that we're going to learn in this class. We're going to understand programming structures. and how they work. Brackets, braces, parentheses. We're going to talk about what goes inside of those items. Square brackets are associated with arrays, braces are associated with blocks of code, and parentheses are associated with arguments or parameters. A condition might be considered an argument. I like to also think of anything that is inside of parentheses as necessary pieces of information in order for the following code block to execute properly. Commas are used to separate items in an array or arguments in a function. We'll get into all of this stuff later. The backslash is used to escape a special character, so it reads like text, and the semicolon, it's to end a statement. There are other operators as well, but we'll get to discussing them bit by bit by bit. So what goes inside of parentheses? I mentioned this a moment ago. Most often we'll see them in if statements. Additionally, anytime we use what is called a method, they will be there too. You can think of anything that goes inside of a set of parentheses as necessary pieces of information in order for the code block that follows to work properly. So what goes inside a curly brace? This is what we call the code block. It is the instructions to be executed. In the case of a conditional statement, code to be executed when the condition is true. In the case of a function, code to be executed when the function is called. In the case of an object, properties and values of that object. What goes inside of brackets? Brackets are the best way to create an array. If empty, you can just create it like, my array equals pair of square brackets. Or with a set of items that you want, milk, cheese, butter. Whenever you hear the term array, think of a list. The first item is an example of how to create an empty array. The second item is an example of a conditional statement. So if x is less than 6, then output is going to equal x times 10. Else, output is going to equal 100 minus x times 10. And then we're going to push that output to an array.
As you know from the previous class, JavaScript is not fault tolerant. You can see the definition of fault tolerance here. In contrast, let's talk about things we know that are fault tolerant. HTML, if you forget to close a div, the browser makes its best guess as to where the div is closed and inserts that closing div tag in what we call the live DOM. HTML is pretty straightforward, so the programming that goes into the browser to figure that out is not so difficult, and the browser can make a good guess and be right most of the time. CSS, if you forget a semicolon at the end of a declaration, it skips the rest of those styles for that selector and goes on to the next one. Again, not a hard thing for the browser program to figure out. JavaScript, on the other hand, is far more complex. It gets interpreted by the browser, program stops in the case of many error types. For example, if you have a reference error, the browser cannot guess what that is. It will just stop instead. You can build fault tolerance into your JavaScript program, that is, what to do when an error occurs, but that is still you telling the computer what to do. It is not built in.
So we'll talk a little bit about coding conventions. A convention suggestion, it's what's typically expected. Whenever you look at somebody's code, these are the expectations that we have. While your code will probably work without those expectations, it's considered a best practice to follow these conventions. Coding conventions secure quality. They improve code readability, and they make code easier to maintain.
And they can be documented in your company's code style guidelines for teams to follow. Again, for quality control and consistency. For example, Google has a code style guide for JavaScript that is used company-wide. It makes things easier to code in large groups and gets new people up to speed if everyone codes and comments in the same way.
So let's talk a little bit about variables. All JavaScript variables must be identified with unique names within the same scope. So these unique variable names are called identifiers, and identifiers can be short names like X or Y, or more descriptive names like age, sum, total volume. In this case, you'll see my var.
Which is really not a good identifier, but this is just an example. I like to name variables after nouns because they are things, whereas functions I like to name with verbs or action words because they do things. This also helps keep you from overriding a function with a variable, which is a horrible mistake I have made myself. Don't do it. With the advent of ES6, we get new keywords to make variables with, and they do different things as we see in this chart. var has existed as a variable keyword since JavaScript was created. This is seen in a lot of legacy JavaScript and used by programmers who have been using the language before ES6. You can see in this chart two terms you are probably unfamiliar with: scope and hoisted. You will need to have a basic understanding of how scope and hoisting works, but we won't go into it in detail here. We will be talking about it throughout the course. Const and let were added to ES6 in order to make JavaScript more friendly to programmers who use other languages and were more familiar with what is called block scope. Scope refers to the areas in your code where you can access that item and its value. Hoisting refers to where JavaScript stores the variable in memory. Hoisted means it goes to the top of the script automatically, no matter where it was written. In ES5, functions and variables are automatically hoisted. When you use const and let, which are ES6, they are not. This means that you cannot refer to that variable if it is written into the script further down. Const stands for constant, which is why you cannot update it. This variable is supposed to store something that cannot be changed. For example, if you have a path to a folder that you are going to refer to multiple times, you don't have to write out the complete path each time. You store it in a variable and you can keep referring to it over and over, thus saving you keystrokes and making for a more efficient program. Let is the new variable keyword that is being used today. As I said earlier, this is to help programmers from other languages transition into JavaScript, but its usage is considered a best practice.
So naming rules, there are definite rules and then there are conventions. So all variable names must begin with an underscore, a scalar, or a letter. Let me take a moment and tell you the $sign I refer to as a scalar, and that's because my PHP teacher pounded this into my head. It's not a $sign, it's a scalar. We're talking about code here, we're not talking about money. We're talking about code, it's a scalar. So you will hear me refer to the $sign symbol as a scalar. So it has to begin with this underscore, a scalar, or a letter. It cannot start with a number. It cannot start with a special character. It can contain letters, digits, underscores, or scalars. It cannot contain dashes or other special characters. Names are case sensitive, so a variable lowercase y and uppercase y are two different variables. Reserved words like JavaScript keywords cannot be used as variable names. Naming conventions. Typically what we will use is called camel casing, where words are compounded with each other. So as you saw earlier in the case of my var. In this case, we have var my string, var my number, and even function names should be similarly done. My recommendation to you is that you do camel casing and you try to make your variable descriptive enough so that you know what it is.
Naming your variables and functions are sometimes thought of as difficult, and you'll see why as this class progresses in our various demos. But let's look at this example.
Pirate, Ninja, and Wizard are pretty cool variable names, but if Pirate equals 5 and Ninja equals Morgan and Wizard equals an array of pirate sayings, we won't remember what those items are representative of when we have to use it elsewhere in our code. Something like this would make more sense. Var Pirates 5, var Pirate Captain Morgan, var Pirate Sayings, Pieces of 8, Walk the Plank, R-Matey, and Dead Men Tell No Tales. As I mentioned, we were going to talk about scope. We're going to have an example, some code examples of scope, including let, so that you can see the difference between var and let. That's an important distinction. Scope defines where variables and functions are accessible inside of your program. In JavaScript, as we mentioned, there are actually now 3 kinds of scope: global scope, function scope, and block level scope. And as I said, we will do some examples right now.